All right, Chapter 4, Section 5, Solving Quadratics Using the Quadratic Formula. All right, so this crazy looking thing right here is what we call the quadratic formula. In another video that I'll provide in the resources, I'll show you where it comes from. For right now, just to kind of suffice it to say, just where it actually comes from. This is taking the standard form of a quadratic, something we are familiar with now for a couple of chapters, this ax squared plus bx plus c equaling 0. It's a very, very advanced way of taking this quadratic equation, this standard quadratic, and isolating x. And you can see how much of a mess it is, right? That's part of the reason why when we teach the different methods on how to solve a quadratic, we don't try and isolate x in this case. This is the version of that, but here's just like jumping you to the finish line. It is a longer process and kind of complex. It involves inverse operations. It's not impossible. And if you wish to see where it comes from and how it's done, you can check out that other video. But for right now, this is the quadratic formula. Now, what will the quadratic formula be used for? Okay, and how do you use it? So the quadratic formula, I give you a couple of little asterisks over here, a couple of little bullet points to understand how it's used. This can be used for any quadratic, okay? And the reason I make that point is because in the sections leading up to this, there were some easier ways to use the methods and some situations where I couldn't use those methods efficiently. The one I'll bring up will be what we covered in section 3 about solving quadratics with square roots, where kind of the main operating function there that I wanted to avoid was having this bx term here in the middle, because it'd be harder to isolate the x squared at that point. Not that it's impossible, it's just that it's a lot more difficult. But here's the good news again, quadratic formula, you can use this for any quadratic equation. All you need to identify are what these coefficients are, a, b, and c, all right? A, b, and c. A being the coefficient that's multiplied by x squared, b being the coefficient that's multiplied by x, c being the one that's not multiplied by any x at all, okay? The one stipulation here, the one kind of rule you have to follow is this little third bullet point, this third asterisk right here, and that's that it does need to be set equal to 0, all right? So if there is other stuff, other numbers, other variables, whatever it might be, I want to move them away to the other side with the other stuff combining like terms, whatever it might be, so that I do have it set equal to 0. That's really the one rule. Once I have that, I can identify those 3 coefficients, and literally it just becomes plug it into this mess and do the calculator work. All right, so let's jump right into our examples. These are going to be the 2 that we do today. And so they'll both be very similar. And quite frankly, they'll both be very straightforward because we're just plugging in the coefficients. It's just a little tedious. It takes a little bit of time to get used to like the order of operations, because literally every single operation that we've covered so far in math is represented here. Okay, exponents, multiplication, division, addition, subtraction. It's all happening. So you have to be very careful about the order of operations. So let's go ahead and jump right in. All right, so we're on whiteboard now. Let's do our first one. Our task here is to solve, not unlike everything else we have been doing in this unit. So our result, our answer, will ultimately be an x equals something. And just relating it back to what we did in section 2, if I were to visually graph either of these quadratics that we're going to see in our examples, I'd be looking for where they cross the x-axis. So I'm going to still end up with those x-intercepts. It's just now I'm going to be using a different method to find them. Okay, and so our first example today, we are given this quadratic. We're given 2x squared minus 5x plus 3 equals 0. All right, so we're going to use the quadratic formula to solve for this. Really, all we need to be able to do is identify what a, b, and c are. And so a, again, is going to be the coefficient that's multiplied by x squared here. So that's going to be this positive 2. All right, make sure you keep whatever sign is out in front along with it. There's no sign out there. So again, this is just a positive 2. B is going to be this negative 5 multiplied by x. So again, just make sure you're keeping track of whatever sign's in front. And then C is going to be the other number. It's going to be the coefficient that does not have an x attached to it. Again, I'm able to just identify A, B, and C here because there is already a 0 on the side. If there was anything else over here, first take the time to move it to the side, combining it with whichever like term it may have. Then it'll be set equal to 0. If there is anything over here, then when you're trying to solve for it, you'll end up with the wrong A, B, or C. So please make sure you move whatever you need to over to the other side using inverse operations. We're going to come across that in our next example. But for right now, A, B, and C are identified. So just to rewrite our quadratic equation, just to rewrite what it is, you don't have to do this on your assignment or show work. This is mostly just so we can see it visually on this whiteboard. Our quadratic equation is as follows: negative b plus or minus the square root of b squared minus 4ac. All of that mess is over 2 times a, where a, b, and c are these coefficients. All right, so all we're literally going to do is plug in those coefficients, those values, that 2, -5, and 3, into their corresponding pieces, and we're just going to do the order of operations. We're just going to solve it out. So there's a lot happening here, and even for a math expert like me, I still need to go through a couple of steps of figuring out what values go where, so I don't lose track of sneaky things like those negatives and stuff like that. So let's take a step to just show what's going to happen when I plug in these values. All right, so x equals negative b. I always take the time to draw that negative sign first, even if this ends up being positive, but you'll see what I'm saying. All right, so negative b. B in this case was a -5. And again, I take the time to do this because what you'll find in this case, b was already negative. So a negative, this is going to turn into a +5 ultimately. But I do take the time to write that out. All right, now negative b plus or minus the square root of the following. Right? B squared, that b is still -5. I'm just going to square it, minus 4 times a times c. Now a, in this case, was the +2 that was multiplied by the x squared, and c was the lone number being +3, right? And you'll notice I put in the parentheses there. The parentheses there are just kind of for 2 reasons, just to kind of signify that that's replacing the a in that case. That one's replacing the c in that case, showing the substitution. But also, if there ever happens to be a negative, I can keep track of that sign along the way. Right? And then lastly, all of this mess is going to be divided by 2 times a again being replaced by that +2 that was multiplied by the x squared. So this is still pretty scary looking, right? There's a lot going on, but just for the record, there are no more variables left in there. I can literally just do all of the operations now. And so here's again where I take a step to kind of clean up some of this mess. Some of you will be able to do some of the stuff in your head and do multiple steps at once, but it is worth doing this like methodically to simplify things, because there is so much going on. It's very easy to lose track of negatives, to lose track of the order of operations that you need to do. So the first thing I do is I clean this guy up. In this case, I do need to change the sign here. A negative is going to turn into a +5. It's still going to be plus or minus the square root of the following, but now let me clean this mess up. All right, so a -5 squared is the same thing as -5 times -5. The negatives will cancel, and I'll be left with +25. I'm going to subtract 4 times a times c, and I always take the time to write that subtraction sign again, even if I get a negative result here, because if I get a negative result, I can visually see like, oh, I need to change that to plus. Again, that's where a lot of students make that mistake. But let me do the 4 times a times c here. I just do it in order. 4 times 2, that's 8. That 8 times 3 gives me 24. And so I'm going to subtract that 24. Now, had one of those been a negative and I had a negative result there, again, I would take the time to actually draw on that negative and then flip the sign next. But again, just to kind of compartmentalize stuff. Now, all of this is over 2 times a. That 2 times 2 is just going to be 4. All right, one step closer. All right, I'm going to go ahead and do 2 steps in one here. Actually, no, I'm going to show the next step that I would do at this point, even though it can be done pretty quickly. Many of you would do it in one step, one go right here. Many of you would do like, all right, well, 25 minus 24, that's just 1. and then the square root of 1. Well, that's simple enough. That's just 1. Okay, but I'm going to go ahead and show this because it won't always be so friendly. Okay, so x in this case, that positive 5 is still there just to kind of show what happens underneath that square root. Plus or minus the square root of 25 minus 24. Not that, again, this is very difficult, but that's going to end up being 1. And then this will all be over 4 still. Okay. Again, I take the time to do this operation underneath. It will not always be so friendly. But now at this point, again, if it isn't so friendly, I would treat this just like we did in section 1. In section 1, I reduce or simplify a radical as much as possible. This one happens to be a perfect square already. So when I take the square root of 1, it will pop out 1, a nice friendly result. It will not always be that case. Particularly if it's something unfriendly and maybe it can't be simplified further, double check to see what the question is asking for. Sometimes they'll ask you to round an answer, in which case use the calculator, round it as you need. Okay, but just to kind of do this now in one step, now this will be 5 plus or minus the actual square root of 1, and the square root of 1 is in fact just 1, right? And then this all will be over 4. All right, so now this looks a lot cleaner, right? X is going to be 5 plus or minus 1 over 4. Now this plus or minus represents the two possible solutions right here. Technically speaking, I now have two equations, right? And here are going to be the two equations. X equals 5 plus 1 over 4 and X equals 5 minus 1 over 4. So that's where that plus or minus goes. All right, so just to wrap this up right now. So to actually simplify this, 5 plus 1 is 6. 6 over 4 is going to give me a fraction. I can either put that in decimal form, which would be 1.5, or I could reduce it to 3 over 2. Okay, which again represents an x-intercept for whatever this parabola looks like on the coordinate grid. In this case, this one will be a little bit friendlier. 5 minus 1 is 4. That 4 divided by 4 gives me positive 1. These are the two solutions to this quadratic. Positive 1 and 1.5 or 3/2. Be careful about how Big Ideas asks you to fill in the answer. If it does want it in fraction form, in this case, that's what this one will be. If it wants decimals round to a certain place, just make sure you're following that closely as well. But in this case, I have two solutions. So if I were to graph the original quadratic that was given, these would be the two places that it crosses that x-axis. All right, let's do one more example. Bring this back up to the top. And we're going to see something slightly different with this example. So let me go ahead and actually, after I erase this, let me jump back to our notes so you can see the question because it's a word problem. Okay, so here is our word problem right here. All right, we're told that the number y of wolf breeding pairs, so y is going to represent pairs of wolves, right? X years since 1990. So X is going to represent, our other variable is going to represent years since 1990, right? And then we're given the following quadratic. A lot more complicated looking than the one we just did. This one's got decimals and stuff involved with it. But we're given this quadratic nonetheless. Again, and here's one of the advantages to a quadratic formula where we can just plug values in. It doesn't matter how complex those values are. We're just doing the calculator work. Okay. And then they tell us one other piece of information here, or ask us one question using this. When were there 35 breeding pairs? What they've just given us is one of the variables. Y represented breeding pairs. So if there are 35 breeding pairs that we're trying to find the answer for, 35 is Y. So what we're going to be doing is plugging 35 in for that Y value there and then solving for X. All right, so let's do this on whiteboard. The original quadratic we were given is as follows. We were given y, let me give myself a little more room, y equals, and then we were given 0.20x squared, and then it was plus 1.8x, and then minus 3. All right, so as it's written, there is an A, B, and C. That would be A, that would be B, and that would be C. But again, the other piece of information they gave us was that we were asked to find when there were 35 wolf breeding pairs. In other words, they're telling us Y is 35, so I can literally replace that Y with a 35. Nothing changed with the rest of the quadratic, but we're left with this result now. 0.20x squared plus 1.8x and minus 3 still. All right, but now replacing that Y with the 35 that we're trying to solve for. And our job here is to solve, to find out what X has to equal to make this true. We're going to use the quadratic formula here, but again, one thing I want to point out. I don't have it set equal to 0. In other words, I want to take this 35 and combine it with one of its like terms. It'll end up being this guy right here, the -3. But in order to move this 35 over this equal sign to cross that bridge, I got to use an inverse operation. That's a positive 35. So the way that I'm going to move it is by subtracting 35 from both sides. This is an important pre-step when it comes to using the quadratic formula. I need one of the sides to equal 0. And we're going to get that right here. 35 minus 35 will officially give me a 0 value. It doesn't matter if it's on the left or the right. As long as one of the sides of the equal sign equals 0, then I will have the ability to use the quadratic formula. So 0.20x squared stayed the same. 1.8x stayed the same because the 35 couldn't combine with either of those. This guy I will be able to combine. -3 minus 35 gives me a -38. So for the record, this is the same exact quadratic equation. It's just now been adjusted for that other piece of information that we were given. So now that I use the quadratic formula, so let's go ahead and just slide down here and deal with this guy at this point. There we go. All right. So at this point, now I want to use quadratic formula. So like I said before in the last example, it's just important to identify what A, B, and C are. A being this 0.20. Positive 0.28 to be more specific, B being this positive 1.8, and C being this newly formed -38. Again, I can jump right to this because now it's set equal to 0. So at this point, I'm just plugging directly into my quadratic formula. I'm going to skip writing the quadratic formula now. Again, we should have it in our notes at this point. So now it's just going to be the substitution part. X equals -B. So I write that negative sign. I take the time to write that. And B in this case now is a positive 1.8. So I'm not going to get the double negative here that I did in the last example, which is fine. So this, when I simplify it, will just stay -1.8. Plus or minus, and then the massive square root. And then here I'm going to have the B squared. So that same positive 1.8. I'm going to square it. And then I'm going to subtract 4 times A times C. So A in this case is that 0.20 or 0.2. I don't need that second 0 technically. Don't know why I wrote it. And then in this case, C would be -38. All right. Sorry if it's getting a little smushed here. These are fat markers. You should get some finer tip ones. All of this mess is going to be over 2 times A. A again is still that 0.20 or 0.2. Okay, so we have officially substituted in, and just like before, I'm going to demonstrate with a couple of steps just what to do to kind of compartmentalize this work. So I still have X equals, and now I'm going to simplify some stuff. A negative version of 1.8 is now a -1.8. Plus or minus still. And now I'm going to simplify the stuff that's underneath this square root hat. 1.8 squared. I'm not going to expect you to have that memorized. That's where the magic tool of a calculator comes into play. So if I square 1.8 or multiply 1.8 by itself, I end up with the value of 3.24. Don't be a hero. Use calculators. So 1.8 squared gives me 3.24. I am now going to subtract. Again, I always go through the time of writing out that minus sign, whatever happens over here. So now I'm going to multiply 4 times 0.2 times -38. Again, don't be a hero. Use some calculators, right? So 4 times 0.20 or 0.2 times negative 38. Right, so I'll make sure I make that a negative. Now I'm going to give me a negative 30.4 result. So again, the fact that I wrote that minus sign, now I'm just going to show that I get that negative result there. All right, I will fix that and turn that into plus in just a second. I know it will be plus. Okay, and then all of this mess is going to be over that 2 times a, which again, I can do on a calculator. This one's friendly enough. This one's going to end up being, I don't need the parentheses there, but it's going to end up being 0.4. 0.4, 4/10, whatever. All right, just so I can save myself a little space on my whiteboard, I'll go ahead and change this guy right now. I had a lot of students that would just make this into a massive plus sign when they see the 2 negatives, but I'll go ahead and just change that right now. Minus a negative will in fact give me plus right there. Great. All right, so now I'm going to take care of what's underneath the square root. And so in this case, I'm going to get x equals that negative 1.8 still, plus or minus. And then underneath my square root, I'm going to condense this guy a little bit more, 3.24 plus 30.4. Again, don't be a hero, use a calculator, right? 3.24 plus 30.4 gives me 33.64. So 33.64 goes underneath here. This is all still over 0.4. All right, well, now I can take the square root of this and just be aware. Again, at this point, this is where I usually double check, like, all right, is the question going to ask me to simplify to the nearest 10th, 100th, how many decimal places, that sort of thing. Because at this point, I'm still in an exact answer form. 33.64 wasn't rounded any at all. This is literally what I will have, but square root of that might be messy, right? And so in that case, I just double check, like, what kind of answer are they looking for? Do they want exact? Because if it's exact, technically this is exact and probably as exact as it will get. But let's keep going. So if I were to actually do the square root of 33.64, let's see what would happen, right? So 33.64, if I take the square root, well, it's friendly enough, 5.8, right? And so when I simplify this a little bit further, I get negative 1.8 plus or minus positive 5.8. That ended up being friendly enough. And all of this is still over 0.4. All right, so this now, I have to remember that this plus or minus represents 2 different equations. So let's write out those equations at this point. All right, so I'm going to get 2 different results here. X is going to equal, all right, a negative 1.8 plus 5.8. I usually do the positive first, all over 0.4. And that will give me some answer. And X also equals that negative 1.8 minus 5.8 all over 0.4. Again, there's that plus and minus that was represented right here. And now if I were to do this on a calculator, this one will be a little bit easier. Negative 1.8 plus 5.8, doing on the calculator, I get 4 for that numerator. 4 divided by 0.4, if I were to do that again on a calculator, x equals positive 10. That's one of the x-intercepts right there. And if I were to do this one over here, trust me when I just talked through it, negative 1.8 minus 5.8 will give me negative 7.6. That negative 7.6 divided by 0.4 will give me negative 19. Negative 19. Don't take my word for it. You can check that on a calculator as well. But these would end up being my results, which happen to be pretty friendly at the end of the spectrum, even though a lot of the stuff in between looked pretty messy. But if I were to have graphed this parabola, even though it had some pretty crazy stuff going on with the numbers at the beginning, it would actually end up having pretty friendly x-intercepts, positive 10 and negative 19. And so back to what the question was asking, where it said, when were there 35 breeding pairs of these wolves? Again, X represented years since 1990. A positive 10 means 1990 plus 10, or the year 2000. The negative 19 would mean technically I'd go back in time. But if I subtracted 19 years from 1990, that would bring me back to 1971. So that would have been 1971 in the year 2000 when there were 35 breeding pairs of wolves. And we'll go ahead and stop the recording there, and we'll finish up this section tomorrow.